All right, so this is problem number 4 for solving 3-variable system. And let's start off by numbering our equations, just like we did in all the previous problems. And I need to eliminate a variable. So I need to pick 2 equations and get a variable to eliminate. Well, if I look at all of these equations, the y's are all 2y. Either they're positive or negative. Well, so I'm going to eliminate y just because that'll be the easiest thing to do. It does not matter which variable you choose to start with. You pick. I like to find the easiest route and take that route. And all the other problems in problems 1, 2, and 3, we always started with equations 1 and 2 and eliminated that variable. But if we look at this, if I start with equation 3, I don't need to multiply anything because equation 1 has a negative 2 and equation 3 is a positive 2. If I were to do equations 1 and 2, I'd have to multiply one of them by a negative to get me that positive 2. So I'm not going to use equations 1 and 2. I'm going to use equations 1 and 3 because then I can just write them out the way they are. And 3 is 2x plus 2y plus 2z equals 12. Those equations look very, very similar. All right. So I add up my x's, I get 4x. Add up the y's, they add up to 0. Add up the z's, I get 4z. And 12 plus 12 is 24. All right. So that gave me equation number 4. Ooh. Things just jumped. Sorry about that. Equation number 4. All right, let's get our equation number 5. We have to use the second equation this time because we did not use it the first time. But that's a negative 2y. So I'm going to still use equation 3 because it has a positive 2y. Oops. So I'm going to use equation 2. And that is 10x minus 2y plus 10z equals 60. And I'm going to use equation 3. 2x plus 2y plus 2z equals 12. And I'm going to add all those together. So I get 12x, the y's add up to 0. I get 12z, and that's going to equal 72. So that makes my, let's pick a color I haven't used yet. That makes my equation 5. Ooh, that's a horrible color. I'm not going to use that color. Sorry about that. Ooh, that was really bright. This is a little brighter of a blue. Okay, so that makes equation 5. So now I have equation 4 and equation 5. I need to eliminate either x or z. So let's just start with equation 4. Let's just get rid of x's. So I need this 4x to be a negative 12, so it adds up to a positive 12 to be 0. So I'm going to multiply equation 4 by a negative 3. So I get negative 12x minus 12z equals what? Negative 72. All right. And then I'm going to leave equation 5 the same because that will eliminate my x's. So I just rewrite equation 5. And if I add those up, my x's add up to 0. Uh-oh, this time my z's add up to 0. But so does my 72's. So I actually have 0 equals 0, which is a true statement. So my answer is actually infinite solutions. It means these are all the same equation. Okay? The thing is, now the book, infinite solutions, you telling me there's an infinite amount of solutions is great. But the book will then want it in terms of a variable. All right, so if we solve in terms of x, and the book will tell you which variable to solve for, we're going to say, okay, I know in my solution that in terms of x means x is x, okay? So if x, this is so weird to say, if x is x, I take one of these equations, I work my way back up, and I'm going to say, okay, well, x is x, so I'm leaving it in my equation. And I need to solve for z. Okay? So if I solve this for z, I subtract 4x to both sides. So I get a negative 4x plus 24. And I divide everything by 4. I get z is a negative x plus 6. So that's what z equals. So in here, I'm going to say negative x plus 6. And when we started this, we have to start with one of our 3 variable systems. I now know x is x, and I know z is a negative x plus 6. So I'm actually going to plug them in. Sorry about that. And I'm going to plug in, I said x is x, so I'm leaving it there. I don't know why, but I know z is a negative x plus 6. And that's going to equal 12. And I solve. So these ones that are infinite solutions are just look a little messier. It'll come out to be okay though. So I have 2x minus 2y minus 2x plus 12, because you got to distribute that 2 to both things in parentheses, equals 12. All right, let's collect some like terms here. Well, a positive 2x and a minus 2x add up to 0. So I'm left with negative 2y plus 12 equals 12. Subtract 12 from both sides. Negative 2y equals 12. Divide by 2. Y equals negative 6. I'm totally just joking. Oh my gosh. I apologize. Let's go back just a step. I said negative 2y plus 12 equals 12. And then I said if I subtract 12 from both sides, I said I get 12. No, I don't. You get 0. 12 minus 12 is 0. I think I tried to rush the end of the problem. But see, we all do that, so it happens. So if I divide by a negative 2, I actually get y is 0. All right, so there is my solution in terms of x. So when you're solving those infinite solutions, you will get a variable, you'll get a number, and you'll get something in terms of another variable, okay? So that is the notes for solving by elimination.